There's a white crystal, roughly $8 a bag, that behaves like nothing else you've got in your house. Leave it sitting in a hot room, and as the afternoon builds toward its worst hour, this crystal starts eating the heat instead of you. No plug, no compressor, no moving parts. And when the sun goes down, it quietly resets itself for free, ready to do the exact same job again tomorrow. Scientists have known about this stuff for decades. It's been tested in real buildings, and almost nobody has it sitting in their bedroom right now. So what is it? Why does it work? And why did something this cheap basically disappear from the conversation? Let's get into it. This is Hidden Fix Lab. Here's the problem everyone's stuck with. When a room overheats, you've got two options. Run the AC and watch your bill climb, or just suffer through it with a fan pushing the same hot air around. Neither one actually stores or absorbs heat. They either burn energy fighting it in real time or do nothing at all. What almost nobody talks about is a third option, a material that just soaks the heat up and holds it, no electricity required, the same way a sponge holds water instead of pushing it away. You've actually felt this kind of chemistry before, even if you never thought about it. Ever snapped one of those reusable hand warmers, the little pouch with liquid and a metal disc inside? You click it, and the liquid turns solid right in front of you, pouring out heat as it goes. That's a salt-changing state, and the change of state itself is what releases the warmth. Now flip that idea in your head. If a salt gives off heat when it turns solid, then logically, a salt melting from solid to liquid should do the opposite. It should pull heat in. That's not a hand-wavy guess. It's basic thermodynamics, and it's exactly the principle behind a specific mineral that's been sitting in cooling research for most of a century: Glauber's salt. Glauber's salt is just sodium sulfate decahydrate, plain, cheap, non-flammable, sold in bulk for basic household and industrial uses. In the 1940s, an engineer named Maria Telkis started experimenting with it as a way to store solar heat for buildings. And researchers have kept coming back to it ever since because it's one of the cheapest materials on the planet with a genuinely large capacity to absorb heat without catching fire or costing a fortune. Here's the part that actually explains why it works, and it comes down to a distinction most people never learned. There are two kinds of heat. One is sensible heat, the kind a thermometer tracks. Add it, temperature rises. Simple. But there's a second kind called latent heat, and it's stranger. Picture a glass of ice water sitting on your counter. As long as there's still ice floating in it, the water stays locked at freezing, no matter how much warm air is hitting the glass. All that incoming heat isn't raising the temperature at all. It's being swallowed by the ice as it melts. Once every last piece of ice is gone, only then does the temperature start climbing again. Glauber's salt does the same trick, just at a different temperature. It melts at around 90 degrees Celsius. So as a hot room climbs toward that number, the salt starts melting and absorbs an enormous amount of heat, while barely changing temperature itself. The room's climb toward its worst, most brutal peak gets slowed and flattened, because the heat that would have pushed the air hotter is getting soaked up by the melting crystal instead. Pound for pound, it absorbs far more heat this way than the same amount of stone, brick, or even water could by simply warming up. That's the entire trick. It's not fighting the heat, it's hiding it inside a phase change until night comes. And I want to be straight with you about what this actually is, because there's a real difference between honest and exaggerated. This does not refrigerate your room. It won't make a 95s get your worst day feel like 72 degrees. What it does is stop the room from reaching its absolute worst. It shaves off the peak. Think of it as the difference between a room that becomes unbearable by 4 p.m. and one that stays merely uncomfortable. That's genuinely valuable, but it's not magic, and it only works in climates where nights actually cool down, because that's when the melted salt refreezes and resets for the next day. If your nights stay hot too, the salt stays liquid and stops absorbing anything new. So if the science is real and it's been published for decades, why isn't this sitting on shelves next to every box fan in the country? Follow the incentives for a second. This is a material that costs a few dollars, has no moving parts to replace, needs no electricity, isn't under any meaningful patent, and this is the real problem for anyone trying to sell you something. It never runs out. You don't buy a new bag every month. You seal it once and it works itself for years. There's no filter to change, no subscription, no recurring purchase. Compare that to an air conditioner or cooling gadget with a business model built around parts, power, and repeat sales. A crystal that resets itself for free overnight just doesn't fit that model, so it quietly stayed in engineering journals and pilot building projects, instead of turning into a consumer product. Now, the practical part. How you'd actually use this. The raw salt has two known quirks, and both have simple fixes that researchers worked out decades ago. First, Glauber's salt can supercool, meaning it drops below its freezing point at night without actually solidifying. staying stuck as a liquid and refusing to reset. Mixing in a small amount of borax gives the salt something to crystallize around, so it reliably resets every night instead of getting stuck. Second, over many melt and freeze cycles, the salt can separate and lose some of its capacity. A small amount of a thickening or gelling agent keeps everything bound together, so it keeps performing over hundreds of cycles instead of degrading. Once you've got that stabilized mixture, it has to be sealed. It turns to liquid every day and it's mildly corrosive, so it needs a sturdy sealed container, never left loose. Flat, sealed pouches or bottles work well because more surface area means faster heat absorption. Place those containers wherever the room heats up hardest, near a sunny window, along a wall that bakes in the afternoon sun. Then, at night, open the windows and let the room cool naturally. That's what recharges the salt for the next day. The more sealed salt you place, the more heat it can buffer, so scale it to the size of the room you're trying to protect. This isn't for every climate, and it isn't for every situation, and I'd rather tell you that now than have you disappointed later. If your nights stay hot and humid with no real drop in temperature, the salt never gets the chance to reset, and it'll just sit there melted and useless. But if you're dealing with a hot afternoon followed by a cooler evening, a sunny upstairs bedroom, a workshop, a tiny home, a rental where you can't install anything permanent, this is one of the cheapest, lowest effort heat buffers you can build with your own hands. And what's real here is real. A genuinely cheap, reusable, non-flammable material that flattens the worst of the day's heat using nothing but basic chemistry that's been documented for 80 years. What's not real is the idea that it replaces air conditioning outright, or that it works everywhere, or that it's some secret being hidden from you by shadowy forces. It's simpler than that. It's just a product nobody could figure out how to keep selling you. And now that you know what it actually is, that's not their decision to make for you anymore.